Hey everyone, I thought I would do a video showing answers to the homework for lesson 2B. This was a photocopied sheet from that other textbook that we used. You were supposed to do page 284, numbers 1, 3, 5, 8, 9, 14 and 16 was enrichment along with number 9. So I thought I could do some of the odd ones here for you at first, and if you want to see the evens as well, we can do that. But for now, let's start with number 1. It says solve for x, and it has the square root of x is equal to 5. Okay, so this is a radical equation, and the general method is you have to isolate the radical and then square both sides and then solve from there. So the radical is already isolated, so I am going to square both sides. The square root of x squared just leaves x. 5 squared is 25. And we usually have to check our answers to watch out for extraneous roots, but if I were to put 25 in for x, the square root of 25 is 5, so that works. Letter C looks like this. I think I may have already did this one. I may have already done this one in the lesson. But let's give it a try anyway. Get the radical by itself. Divide both sides by 2. So we have the square root of x is equal to 2 root 3. And now we are ready to square both sides. So squared, squared. The square root of x squared leaves us with x. Everything gets squared on the right-hand side. 2 squared is 4 times the square root of 3 squared is just 3. So it's 4 times 3 over there, and we get x equals 12. Okay, and if I put 12 in there, I'm not going to get that the square root of something is working out to a negative, so that looks like a good answer. Let's try letter E. We have the square root of 3x plus 1 is equal to 7. I'm going to isolate the radical first, so subtract 1 from both sides. We have the square root of 3x is equal to 6. And now that the radical is by itself, we are going to square both sides. The square root of 3x squared is 3x, and 6 squared is 36. Divide both sides by 3. And we end up getting x equals 12. So if I put 12 back in for x, we would have 3 times 12 is 36. The square root of 36 is 6. 6 plus 1 is 7, so that works. And that is how you do number 1. Okay, let's check out number 3. A says the square root of 3x plus 1 is equal to 7. The radical is by itself already, so square both sides. Seven squared is 49. And we subtract 1 from both sides. X is equal to 48. Divide both sides by 3. (48) divided by 3 is 16. And if I do a quick check, 16 goes in there. 16 times 3 is 48. 48 plus 1 is 49, and the square root of 49 is 7. So that works. Okay, let's check out letter C. We have 2 times the square root of x is equal to 8. So let's isolate the radical. That's just cancels to 1, so we get the square root of x equals 4. Square both sides. And we end up getting x equals 16. So if I were to put 16 back in there, the square root of 16 is 4. 4 times 2 is 8, so that works. Okay, here is 3e. The square root of x plus 3 is equal to 4. Subtract 3 from both sides. We end up with the square root of x is equal to 1. And then square both sides once the radical is isolated. Square root of x and then squared takes us back to x. 1 squared is 1. Alright, so we'd have to go and plug that in here. The square root of 1 is 1. 1 plus 3 is 4, so that is a good answer. And that's how you do number 3. Okay, here's number 5. A, part 1, it's saying solve. The square root of x minus 2 minus 5 equals 0. Okay, isolate the radical first, so add 5 to both sides. The square root of x minus 2 then is equal to positive 5. Good, that seems okay because you can only have positives coming out of the square root. So we will square both sides. Squaring undoes the square root, so we'll be left with x minus 2. 5 squared is 25. And we're going to add 2 to both sides. To get x by itself, x is equal to 27. 27 minus 2 is 25. Square root of 25 is 5. 5 minus 5 is 0. That's a good answer. Part 3, we have the square root of 2x plus 1 plus a 5 on the outside equals 8. Okay, isolate the radical. Eight minus 5 is 3. Square both sides. This will turn into 2x plus 1, and 3 squared is 9, and that's an easy two-step equation to solve. Subtract 1 from both sides. We will end up with 2x equals 8, so x will be 4, because you divide both sides by 2. And a quick check by inspection. Imagine putting x equals 4 right there. 2 times 4 is 8. 8 plus 1 is 9. The square root of 9 is 3. 3 plus 5 is 8. That's a good answer. And let's check out part 5. We've got negative 2 times the square root of 6x plus 1 equals 14. So let's isolate the radical. Divide both sides by negative 2. And we'll end up getting the square root of 6x plus 1 equals negative 7. Okay, and so this one is going to have an extraneous root because you cannot get a negative answer coming out of a square root. We have the square root of this thing equals negative 7. That is not possible. Just the positive comes out of a square root. So if we continue the process, though, we may get an answer. It's likely will just be extraneous. So I'll square both sides. Squaring a square root undoes those two operations. So we have 6x plus 1, and then notice that negative 7 squared would be the same as positive 7 squared, 49. So that's why we can end up getting extraneous roots. We can then solve this. 6x is equal to 49 minus 1, which is 48. Divide both sides by 6. And we get x equals 8. Okay, but if you put it back into the original equation, 8 times 6 is 48, plus 1 is 49. We have the square root of 49, which is 7. 7 times the negative 2 that was in front there, right here, is negative 14, not positive 14. So we have to reject this. Reject. It's an extraneous root. Okay, and since we are rejecting our only answer, we would say, therefore, no solution. All right, and that is 5A, part 5. All right, let's move down to number 8 here. It says determine by inspection which equations have extraneous roots. And we have the square root of x plus 3, and then plus 5 equals 0. And you might notice, guys, that if you try to isolate the radical, you will get the square root of x plus 3 equals negative 5. We cannot have the square root of something equaling a negative. So this is going to have extraneous roots. I think there'll just be one answer for this one, so it'll be an extraneous root. Okay, and so that's what they mean by inspection. Just sort of looking at the equation without actually solving it. And part C, 4 plus the square root of 2x minus 7 equals 0. We can even do it in a more sophisticated way. 4 plus something equals 0. You'd have to add negative 4. There's no way to get negative 4 out of a square root. Okay, because the only thing out of a square root is positive. So this one will have an extraneous root as well. And you can see it more clearly if you subtract 4 from both sides. We have the square root of 2x minus 7 equals negative 4. That's not possible. Can't get a negative coming out of a square root. So this will have an extraneous root. Okay, how about part E, 8E? 7 plus 5 times the square root of 2x plus 3 equals 4. If you subtract 7 from both sides, we end up getting 5 times the square root of 2x plus 3 equals -3. Divide both sides by 5, and you'll notice that we are going to get a square root being equal to a negative. And so this will have an extraneous root. Again, because you can't have a negative answer from a square root. All right, let's check out number 9 here. The formula for the length of the diagonal of a rectangle with sides of length A and B is diagonal length equals the square root of A squared plus B squared. Solve the formula for A. So we want to get A by itself. Okay, well, A is being squared, and then we're adding B squared, and then we're square rooting. So the opposite of square rooting is squaring. So I'm going to square both sides. And I end up with D squared equals A squared plus B squared. And then subtract B squared from both sides. And we will get D squared minus B squared is equal to A squared. Okay, and then of course, to get A by itself, we would square root and square root. And when you solve equations by the square root method, we have to keep in mind that it could be plus or minus that answer. Yet the square root of D squared minus B squared is equal to the square root of A squared is just A. And I'm going to reject the negative answer because A is a side length. And we wouldn't talk about a negative side length. Okay, so A, yeah, is the side of a rectangle. So we'll reject the negative answer and we'll just use the positive. All right, so that was number 9. Next on the list is 14. A, and we'll do part 1. It says solve the square root of 2x plus 4 equals the square root of x plus 7. Okay, so if you have a radical on each side of the equals sign, they're isolated on each side of their equal sign, so we can go straight to squaring both sides to get rid of the square roots. And we end up with 2x plus 4 equals x plus 7. And this is a linear equation because the highest power of x is x to the 1, so we want x's on the left, numbers on the right. Two x minus x is x. 7 minus 4 is 3. And if I check my answers here, on one side I'm going to get 6 plus 4, the square root of 10. On the other side, 3 plus 7 is 10, square root of 10. No negatives involved or anything weird, so that's a good answer. Here's part 3. the square root of x plus 3 is equal to the square root of 2x minus 1. A radical on each side, they're isolated, so square both sides. X plus 3 is equal to 2x minus 1. Subtract 2x from both sides, subtract 3 from both sides. X minus 2x is negative x, that cancels to 0. 2x minus 2x cancels to 0, and we get negative 1 minus 3 is negative 4. Then divide both sides by negative 1. That will give us x equals negative 4 divided by negative 1 is positive 4. And we have to go and plug it back in here and in here to make sure it works. 4 plus 3 is 7, the square root of 7. 2 times 4 is 8, 8 minus 1 is 7, square root of 7 on both sides. That's a good answer. Let's do number 5 over here. We have the square root of 2x minus 3 plus the square root of x plus 1 equals 0, so we need to isolate the radicals, so subtract this one over. That's going to cancel. So we have the square root of something on one side equals the negative square root of something on the other side. So this is not possible because only positives come out of square roots. This will become positive and you'll have a negative in front. So the right-hand side will ultimately be negative and the left-hand side will be positive. So this is going to have an extraneous root or roots. But if we go through the process, here's what we would get. X minus 3, see, negative squared makes it positive. Square root of x plus 1 squared is x plus 1. Subtract x from both sides, add 3 to both sides. X minus x is x, that cancels. X minus x goes away, 1 plus 3 is 4. And we'll do a quick check. Does the square root of 2 times 4 minus 3 plus the square root of 4 plus 1 equals 0? This would be the square root of 8 minus 3, which is 5, plus the square root of 5. That equals 2 root 5, not 0. So we have to reject this answer. Therefore, since I'm rejecting my only answer, we get no solution. Okay, and finally, number 16. I think I did 16A in the notes, so maybe we could check out 16C. This is an enrichment type exercise. You have to go through the process twice of squaring both sides. Okay, so we need to get the radicals on opposite sides. And now we're going to square both sides. The left-hand side is not a big deal. We gotta square this side here though. Okay, so the left-hand side is just going to work out to 2x minus 3. The right-hand side is going to be this bracket twice, and we have to do FOIL. And we end up getting 5 times 5 is 25. And then 5 times that negative square root thing is negative 5 times that square root. And then this, we get negative 5 times the square root of 2x plus 1. And negative times negative is positive on the end here. The square root of 2x plus 1 times the square root of 2x plus 1, the square roots will cancel, and we're left with 2x plus 1. So we have 2x minus 3 equals 25 plus that 1 on the end is 26, so that takes care of those terms. We've got a positive 2x, and we have negative 5 times that square root thing minus another 5 root 2x plus 1, so that will be negative 10 root 2x plus 1. And so then our job is to isolate that radical and square both sides. And I noticed that I just forgot the x attached to this 2. Okay, so we need to isolate that radical and then square both sides. So let's subtract 26 from both sides. Let's subtract 2x. Wow, that's going to get rid of the 2 x's. That will cancel. We will get negative 29 equals negative 10 times the square root of 2x plus 1. Good, so at least when I divide both sides by negative 10, I'm going to get a positive over there. So the square root of something equals a positive. Let's just go 2.9 for now, I guess. And now we have to square both sides. .9 squared is that, and let's go math and fraction that. 841 over 100 equals 2x plus 1. And then we have to subtract 1 from both sides. .841 over 100 minus 1 is equal to that. As a fraction, 741 over 100. And then divide both sides by 2. So 741 over 100 divided by 2 is that, math, fraction that, 741 over 200. See how it's kind of like the 2 just multiplies onto the bottom number there. Okay, so the answer is 741 over 200. Let's do a check. The original equation was the square root of 2x minus 3 plus the square root of 2x plus 1. Does that equal 5 is the question. And I'm going to put a little barrier down here and do some calculator work. So we are putting 741 over 200 in here. Okay, and we want this left-hand side to work out to 5. So let's get out the calculator. And I'm going to go second function x squared to get square root. We have to have 2 times that fraction, 741 over 200 minus 3, and then I have to close the bracket for that first square root so that the 3 is under the square root as well, plus, open a new square root, 2 times 741 over 200 plus 1, close bracket around the 1. Does this equal 5? Yes! Perfect. Okay, so x equals 741 over 200 is a good answer. Okay, so those are some homework solutions, everyone. If you're working on anything and you want to know the answer, send me an email. We can go from there. Talk to you soon.